go forward to the page on Le Chatelier's principle. Another one of our French chemists. Le Chatelier's. So Q and K comparison was assessing a reaction at any point in time and figuring out what it's going to do, okay, just on its own. Okay? Le Chatelier's principle is where we start with a system that has already reached equilibrium and then we add something to it. Okay? This is what happens when we disturb that equilibrium in one way or another. Okay? So we can change the concentration of reactants or products. So we could add something, reactant or product. We could remove reactant or product. Okay? That will disturb the equilibrium. If it's a gaseous equilibrium, we could change the volume of it. Turns out that will also change concentrations. Right? We can change the temperature of an equilibrium. That will affect things as well. The system will respond in a way that will restore the original equilibrium. Okay? So shifting left, just like we said, forming more reactants. Shifting right, forming more products. That's just the terminology. And of course you guys get that. There's nothing left or right about a reaction. It's just the way we've written it and signifying what side of the equation we wrote is going to get more. Okay? So shifting left means we're going to make more reactants. Shifting right means we're going to make more products in order to reestablish that equilibrium. And the system regains that equilibrium when Q equals K again. So doing two of these things, doing these two things here, will change Q. Okay? Because changing any concentrations of anything, we'll plug those back in and solve for Q. That will change it. Okay? Changing volume actually changes the concentrations as well. Okay? We'll deal with how temperature works. Okay? So remember Q, products over reactants, but at any time. Okay. So if we calculate the new Q compared with K, if Q is too low, what will the reaction do? Think about that. It will produce more products and shift right. Okay? Q is too low. Okay? We shift right. Okay? If Q is too high, opposite. Our shift is left to produce more reactants. Okay? But in either case, the reaction will eventually return to K. Okay? So if we disrupt an equilibrium in such a way that Q changes, right, at equilibrium, Q and K are the same. Okay? If we disrupt it so that we can recalculate Q and change it, okay, we have to then figure out which direction the reaction needs to go in order for that Q to become equal to K again. Okay? Just like we were talking about before. Okay? So, you guys done writing? Ready for me now? All right. This is a cool graph. I think this is helpful in visualizing this. Okay? We are going to change. So changing concentrations obviously changes Q. It does not change K. K is the equilibrium constant for that reaction. Changing the concentrations just messes up our Q, which will then have to re-establish itself back to K. So let's start with our same equilibrium we've been demonstrating the whole time. Let's start with simple values for concentrations at equilibrium. Let's pretend this is 2 and this is 4. Okay? Let's say that it's at equilibrium, and those are just made up numbers, but let's just pretend, just for the sake of simplicity, that when this is at equilibrium, this is over time. Okay? So concentrations are not changing anymore. Okay? They're just sort of sitting there at 2 and 4. And that will tell us what the equilibrium constant is. If this is our equilibrium, what would I have to have on the top of that fraction? So NO2, yep, it has to be NO2, but squared over N2O4. So that would be 4 squared over 2, which is 8. Okay? In each case, here on this page, we're going to do something to screw up that equilibrium, but it's going to adjust, and that Q is going to bring itself back to 8 again, because that's where the equilibrium lies. Okay? So what we're going to do in this first case, we're going to disturb the equilibrium by adding NO2. Okay? We're going to go from 4 to, let's pretend, 5. Okay? Say I keep the NO2, I don't add any N2O4, but it's reached equilibrium, and I just inject some pure NO2 into it. Okay? That will disrupt the equilibrium because this concentration shot up like that. Okay? So what we can do, calculate Q after adding NO2. Would be NO. So right at this point right here, NO2 is now 5, which we have to square. N2O4 is still 2. Okay? It is 12.5. Okay? Our Q is now too high. What do we have to do? What direction will we need to shift this equilibrium in order to get it back to 8?
Left.
Yep, we're going to have to shift it left. Our Q is too high, meaning, and we can see this right here, we've got too much product. We were totally fine with 4 squared over 2. Now we've got 5 squared over 2. We've got too much product. Okay? So look at what happens. Okay? Over time, some of this product is consumed. A little bit more of this reactant is made. Okay? Let's write right in here that Q must decrease. Right? Or in other words, reaction will shift left. Okay, to produce more reactant. Okay, and that's what happens here. Okay, to produce more reactant, our 5 of this product is going to decrease. Our reactant is going to increase. The values that we actually end up with are 4.32 and 2. Red. Okay. So if we put those values in, let's call that Q final. 4.32 squared over 2.34 is pretty close to 8. Two coefficient. We squared it here. Yeah, that coefficient is.
I thought you said it got used in 2 places.
If we were doing an ice table, if we were doing minus x and plus x, okay, all this is just Q and K. We already have all the concentrations of things. Okay? I needed to do that. That's where these numbers came from. I actually needed to use that to calculate these numbers. That's an exercise. But if you're already given all the concentrations, you just need to square if you need to. Okay? So we've returned to 8, and all is right in the universe again. You can imagine a similar type of thing would happen over here if we added this reactant. Now we've got too much reactant. That has to go down. That one has to go up. Okay. So we're out of time. I will talk on this one for just a little bit next time. But we've gone beyond at least where the quiz will be. The quiz will just be those calculations that we talked about. We won't be doing Q's and K's on the quiz, just those calculations. So we'll finish this next time after the quiz, and we're cool. Yes, Tyler.
I missed it in the beginning, but
Yeah.
can you post the video for the lectures online to study for the weekend?
Yeah, I got up through. I think I'm up through last week. I had a little problem with what's today? Wednesday. I had a little problem with Monday. So if I can't get Monday to work, I'll find it from last year, and I'll put it up, and that'll be the same thing. So, yep.
When's the next study guide?
Oh, I can activate that right now.
What, you want to get your hands on that beauty?
Yeah.
No, thanks.
Sink your teeth into that.
I'm just hoping this time that I every time I mean to like put a couple spaces in there, but I don't. I just get the one pager and then I just cram it.
There you go.
Trust me, this guy comes in pretty handy when it comes to final time.
Yep. Okay. Sam two stood again. There you go. Alrighty.